Hi again, everyone. So we talked about momentum and we saw the question in the previous video. I talked about inelastic and elastic collision differences. Basically, energy is conserved in elastic collisions and energy is not conserved in inelastic collisions. As I mentioned, there is a kind of special case for inelastic collisions where you have two masses merged together after the collision. That is called either completely inelastic or perfectly inelastic collision. That's an example I wanted to show in this video. So I just picked two masses with two initial velocities given. Mass 1 is 2 kg, mass 2 is 4 kg, and the initial velocity of the first mass is 6 meters per second toward right, and the initial velocity of the second mass is 2 meters per second toward left. And as we mentioned, toward right is positive, toward left is negative for me. So this direction choices can be made at the beginning of a question, which you should do for example, if two cars are going to collide in a question, one is driving toward north, one is driving toward south, or anything like that. You just assign one to be positive, the other is going to be then negative. Let's say north is positive, then south is going to be negative. Write that definition for yourself at the beginning of the question and just follow that designation of the directions. And your result is going to tell you in which direction the final velocities are going to be then. So in this case, I'm using just toward right and toward left. So obviously, I'm going to use like the XY coordinate system designation, which is toward right is positive, toward left is negative. So when I want to write before the collision total momentum, which is initial total momentum, basically, I need to write each individual momentum of each particle I have. I have two objects in the system, so I'm going to write m1 v1 I for initial velocity, m2 v2 I for initial velocity of the second object. So if you do that, m1 is 2, and velocity for that initially was 6 toward right, so it's positive. M2 is 4, and its velocity is toward left, so it's going to be -2. That's toward left is negative here. So I just put negative here. So the total initial momentum is going to be 12 minus 8, so it is 4 kilogram meter per second. This is the total initial momentum. And as I mentioned before in our questions, the momentum is always going to be conserved because we won't be dealing with any external forces acting on our system. So we know that the total initial momentum is going to stay the same, so it's going to be equal to total final momentum after the collision momentum. So if this collision is perfectly inelastic or completely inelastic, we know them to be merged together after the collision. So I just wrote here what is the total final momentum. It's basically, again, momentum of the first object, momentum of the second object that you will need to add to find the total momentum after the collision, merged together again after the collision. And in this case, because I picked it to be perfectly inelastic, that means they're going to merge together. So their velocities are going to be the same because two objects that merge together move together. So their velocity is going to be the same. So I named it as V final because we don't have two different velocities anymore. And again, the momentum conservation dictates that these two quantities, initial and final momentum, that is total, is the same. This is momentum conservation of momentum. So you know that these two numbers are equal. And previously I found that the total initial momentum was 4, so I just substituted there. 4 is going to be equal to the final total momentum, so I'm writing this expression that I kind of derived from total momentum of these two objects, where you have m1 v final plus m2 v final. Because they merge together, their velocity is the same. So I put these two masses into parentheses. And so because your object merged together, they're like behaving like a total mass of these two objects as one. So it's 2 plus 4 because m1 was 2, as I assigned here, m2 was 4, so it's 2 plus 4. It's when they merge together, their total mass is 6 kilogram. and their common velocity is going to be calculated again from the initial total momentum that we found by calculating here as 4. So I'm using that initial total momentum. 4 is equal 6 times v final. So I divided both sides with 6. Now I gathered the final velocity of our merged final object, and that is 0.67. I just rounded off to 2 digits after the decimal point, and this positive here basically tells me that this merged together object moves towards right. So once again, your direction choices should be clearly identified at the beginning, and which I did here. Toward right is positive, toward left is negative. So I picked my choice and just write it down for myself, and you do the same, because again the questions could be saying toward north, toward south, toward east, toward west. In that case, please write it down for your own reference which direction you chose to be positive. Then the opposite direction is going to be negative, and use that fact in your equations like this. And eventually when you find the final velocity of one or the other, or the both in the case of perfectly inelastic solution, the sign of the velocity is going to tell you in which direction that object is going to be. And in my case, I found it to be positive, so it tells me that these two merged together object is moving toward right. And I hope this is going to help you for perfectly inelastic collision problems. Once again, perfectly inelastic collision is kind of a special case of inelastic collision where you don't have energy conservation. And you know that when you read words completely inelastic or perfectly inelastic collision, you basically are told that these two objects are going to merge together after the collision. This is the fact given when you see the word perfectly inelastic or completely inelastic collision. This is what you need to know, okay? And in that case, because they merge together, their velocity is going to be a common velocity, one velocity now that is going to be found. So I hope, again, this is going to help you for perfectly inelastic or completely inelastic collision problems. Have a good day.